We're now given a theorem that says that a collection of vectors is linearly dependent if and only if one of the vectors is a linear combination of the others. And I wanted to give the argument behind this theorem. So I've written here in blue a reminder of the definition of linear dependence. And that's, well, in here, I've taken this to just a collection of three vectors, just to keep things fairly simple here. So the collection of vectors v1, v2, v3 is linearly dependent if this homogeneous system of equations that corresponds to this vector equation here has a non-trivial solution. And so a non-trivial solution means that at least one of these guys, x1, x2, x3, is non-zero. The trivial solution, remember, is the one where all of these coefficients, x1, x2, x3, have to be 0. And that's what gives you linear independence. But if the collection is linearly dependent, then we have a solution where x1, x2, x3 are not all 0. Okay, so let's suppose, let's just take x1 and suppose that that's not 0. It's fair to assume that one of those is not 0. If x1 is not 0, then we could solve this thing for vector 1 by first x1 v1 would be equal to, we could subtract x2 v2, which is a vector, subtract that from both sides. Also x3 v3. So if we rearrange that vector equation, it would say this, and then divide each of these coefficients by x1, which this we know will work since we've already guaranteed that x1 is not 0. If you do that, this cancels here, and now we've written vector 1 as a linear combination of the other vectors, based only on the assumption that the collection is linearly dependent.